All right, so we're going to go through the solution to the practice test, and this is our longest test yet. It has 9 learning objectives, so we'll do 3 objectives per video. All right, the first one is all about the product rule. So first, what is the product rule? I wrote it out here. So when you're taking the derivative of 2 things being multiplied, all right, so it's f of x times g of x. You keep f of x the same. You multiply by the derivative of g of x. All right, you keep, accidentally messes up this. F should be this should be the prime, and that should not be there. All right, so then you keep g of x the same, and you multiply by the derivative of f of x. All right, so if we do this problem, we have this graph, and we're going to find h prime of 4, but h is defined as f times g of x. So we can kind of just use this expression up here, except for we're going to plug in 4. So we're going to get f of 4, g prime of 4, plus the original g of 4 times f prime of 4. All right, so the function values, the original function values are the ones we can just get from the graph. F of 4, I just plug in 4 and f, and I get 5. G of 4, we just plug in 4 into g, and we get 0. And then the primes, those represent slopes of the tangent line, but for a line, the slope of the tangent line is just the slope of the original line, so f prime is just the slope of this line. It's up 1 over 2, that's 1/2. G prime is the slope of this line, down 1 over 1 is -1. And if you simplify that, you get -5. All right, so B is the right answer for this one by just using the product rule. Here we have some information about f given to us, and we know our g function is x cubed times f of x. So we're going to use the product rule, because it's x cubed times f of x. So g prime of x is going to be keep the first function the same, derivative of the second, which is just f prime. We don't know what f is, so we just put f prime, plus keep the second function the same, derivative of the first using the power rule, is 3x squared. And then we want to plug in 2 into everything. So if we plug in 2, we're going to get 2 cubed. F prime of 2 is given to us, that's 5. F of 2 is given to us, that's 2. And then 3 times 2 squared. Actually, that's 8 times 5 is 40. 4 times 3 is 12 times 2 is 24. So we get 64 as our final answer. So again, just using the product rule, making sure you do the product rule correctly, and then plug in the values that you know. And the last one is a direct application of the product rule. We have e to the x times sine of x. All right, so if we keep e to the x the same, multiply it by the derivative of sine is cosine. Then we add, we keep the sine the same. Multiply by the derivative of e to the x is e to the x. If you know, if you just do that directly, none of these answers match, but both these have an e to the x, so I can factor it out, and I get c as my final answer. So e to the x can come to the front. That leaves behind a positive cosine and a positive sine in the parentheses. In the short answer, same thing. You just have to do it without the multiple choice options. So f prime of x, first one the same. Derivative of cosine is negative sine, so I'm going to put the negative there and put the sine there. All right, plus keep the second one the same. Multiply by the derivative of the first one, so the derivative of x to the 4th is 4x cubed. And the way I generally write it would be like this. So that one's fine. But generally we put the x parts in front of the trig parts. All right, so that would be the final answer for that problem, just using the product rule. So our next learning objectives deals with the quotient rule, which is when you're dividing 2 things. All right, remember it's low d high minus high d low all over low low, or the bottom squared. All right, so in this one, we have h of x, which is defined with this big division bar in the middle. So we have to do the product rule when we find h prime. All right, so to find h prime, we do the original bottom of the fraction, so g of x minus 1, times the derivative of the top. This 6, it's a constant multiple, so that'll stay, but f will turn into f prime of x. Then we subtract the original top function times the derivative of the bottom. The derivative of the bottom is going to be g prime of x. All right, the 1 goes away because you're taking the derivative of a constant all by itself. And that's all over the original bottom squared. But from there, we just plug in the things we know. So g of x is -2. f prime of x is 1/2. I'm going to run out of room. F of x is 4, and g prime of x is 3/2. Right, and all that's over, and g of x is -2 minus 1 squared. All right, so we're going to get -3 times 3 minus 24 times 3/2 is going to be 36, all over -3 squared. So that's -45 over 9, which is -5. That's our final answer is -5. But again, just following the pattern of the quotient rule and plugging in things where they go. All right, 6 is no different. It's in the quotient rule section, so we're going to do the quotient rule. We take the derivative to get g prime of x, original bottom, times the derivative of the top, minus the original top, times the derivative of the bottom. Remember that the cube root of x is x to the 1/3, so the derivative of that is going to be 1/3 x to the -2/3, all over the original bottom squared. And then I want to plug in 8 into all of that, so the cube root of 8 is 2. F prime of x is given to us, that's 5. F of x is given to us, that's 2. Sorry, f of 8 is given to us, 1/3. 8 to the -2/3 is going to be 1/4. And that's all over. Again, the cube root of 8 is 2, so 2 squared is 4. All right, a little bit more simplifying. I'll do it over here. Let's see, 10 minus 2 over 12 is 1 over 6 over 4. Multiply everything by 6 to get 60 minus 1 over 24, which is 59 over 24. Right, but again, following the quotient rule, the most difficult part about this part is remembering how do you do the derivative of the cube root of x, and that's that part there. All right, but still just following the quotient rule. All right, 7, same thing. Quotient rule, natural log of x is going to stay. Cosine turns into negative sign when we take the derivative. Minus now cosine stays. And derivative of the natural log of x is 1 over x. That's all over the original bottom squared. And you'll notice none of them exactly match this one. It's definitely not c, because c doesn't have a fraction at all. All right, so we have a negative natural log of x, sine of x, and a minus cosine. The answer is probably going to be b. So how do we get from what we have to b? If we just multiply everything by x, this will go away. It'll give us an extra x here and an extra x there. All right, so to get rid of that fraction in the top, we multiply everything by x, and that'll give us exactly b for our final answer. And 8, same thing, we're just taking the derivative without the answer choices, so original bottom times the derivative of the top using the power rule, minus the original top times the derivative of the bottom. The derivative of the bottom is cosine, all over the original bottom squared. All right, so that's all we have to do for this. You don't have to FOIL out or distribute and combine like terms. All right, since it says you don't need to simplify, just leave it like that, and that's the final answer. All right, so the final learning objective in this video is about the derivatives of tangent, cotangent, secant, or cosecant. So I went ahead and just wrote those 4 derivatives over here. And again, these are just kind of flashcard things. You just make a flashcard where one side says derivative of tangent, the other side says secant squared. You basically just remember these, and that'll help you a lot. For this first one, we have secant of x, and we're trying to find the limit as we plug these things into f. All right, this here is one of our alternative definitions for the derivative of the function. This looks like an average rate of change. So we have function values on the top and x values on the bottom, and these two values are getting closer and closer. All right, so it's just a version of the derivative. So this basically just says take the derivative of your f function and then plug in pi over 3. So the derivative of secant, as we can see on the right here, is secant tangent. And then since we have pi over 3 as the value we care about, we just put a pi over 3 in there. All right, so that's c. All right, so really this one, in a really complicated way, is basically saying take the derivative of secant and then plug in pi over 3. All right, number 10, there's kind of a simple way to do it and another way to do it. All right, let's do the other way first. All right, the other way is you're trying to take the derivative of cosine times tangent. So you should do the product rule. All right, cosine times tangent, we keep cosine the same. And the derivative of tangent is secant squared. Then we add, we keep tangent the same. And the derivative of cosine is negative sine. But none of those look like the answers we have. All right, so what can we do? Well, cosine times secant. Secant is the same as 1 over cosine. So cosine times secant squared, one of the cosines is going to cancel, and that's going to simplify just to secant. Oops, just secant, I put secant squared. On the right-hand side, tangent is sine over cosine, so nothing cancels out there, but I can write this as sine squared over cosine squared. And let's change secant to 1 over cosine squared. And I also made another mistake, is that there should be a minus sign there coming from that minus from taking the derivative of cosine. So we have 1 minus sine squared over cosine squared, well 1 minus sine squared, sorry, and I also did this too. Made so many mistakes on this one problem. The squareds aren't there because it's just a single cosine. I have a 1 minus sine squared over cosine. The top 1 minus sine squared is the same thing as cosine squared over cosine, and it simplifies to cosine. All right, so this one is actually just B. Seems pretty difficult. You're doing a lot of trig identities and things to simplify this. So the simpler way to do it is before you take the derivative, try to simplify. All right, cosine times tangent. Well, tangent sine over cosine. So the cosines cancel and you get sine. All right, so the thing in parentheses here is just the same as sine, and derivative of sine is cosine. All right, so that's the easier way to do it. You can do it both ways. You might not recognize that you can simplify your equation before you take the derivative, all right, but if you can, it's going to make your derivatives easier. 11 is really just a flashcard. What is the derivative of cotangent? The derivative of cotangent is negative cosecant. That's that one's not anything more to explain other than it's just something you have to have memorized. And 12, again, just taking these derivatives without the answer keys to help you. All right, so x squared times cosecant of x, we have multiplication between x squared and cosecant. So we're going to keep x squared the same. Derivative of cosecant is negative cosecant of x, cotangent of x. Then we're going to add, we're going to keep cosecant the same, and multiply by the derivative of x squared, which is 2x. All right, so you can leave it like that, but again, generally, we'll write the x terms in front of the trig terms. All right, so that's the derivative of this expression. All right, so those are our first 3 learning objectives covered. Now we had the product rule, the quotient rule, which is just rules you have to have memorized. All right, but you're basically just following the pattern of where derivatives go and where original functions go. All right, and then again, these derivatives of these trig functions is basically just things you have to have memorized. All right, just kind of write them down on flashcards until you know what they are as you go through them.